We're talking about analyzing graphs of polynomial functions, and we want to use x-intercepts to graph polynomial functions and find turning points, local maximums, and local minimums. So graph a polynomial function, identify the x-intercept, the y-intercept, and the points where the local maximums and local minimums occur. Determine the interval for which the function is increasing and decreasing. First thing we want to look at is we have our polynomial here. We see its fourth degree, and when we see that, then we understand that we understand that our graph is going to open, our end behavior is going to go in the same direction, and it's a positive coefficient, so that we know that our graph, when we get all set and done with it, it should look something like this for our end behavior. That's because our a value is positive and our highest degree is even. Another thing that we can take a look at the graph right away is we can know our y-intercept. So our y-intercept in this case is -5. So the y-intercept is -5 because if we substitute in 0, this term becomes 0, this term becomes 0, this term becomes 0, this term becomes 0, and all we're left with is -5. And so we can plot -5 on the graph. And this time for our x and y axis, we're going to have -10 and +10. So we're going to count by 2's, and we'll still count by 1's on the x-axis. For the other parts, for the local max, local min, and the x-intercept, we're going to use the graph again to pick those points from. So if we look at our graph, we can see that we have two x-intercepts. We have one x-intercept is -3.074, and the other x-intercept is 1.422. So we can plot those, estimate where they're going to be a little bit past 3, and about halfway between 1 and 2, a little less, when we go to plot that on the x-axis. Another thing that we have to come up with are the local minimums. In this case, we have two local minimums. And one of them is at -2.277 and -9.612. And the other one is 0.676 and -7.025. And so we can estimate where those are as well. -2.27, just a little bit past 2, and almost down to 10, but not quite. And about halfway between 1 and 0, a little bit more than that, and -7. So that's 6, and that's 8. So right about -7. So that puts us right about there. And so now we have enough points. Oh, we have to calculate our maximum also. And our maximum, we can see, comes there at -0.65 and -3.468. So -1 or -0.65 and -3.4, almost 4, but not quite. And so now we have enough points that we can sketch a pretty good graph of what it looks like on our piece of paper. We know that our end behavior is both going to end in the same direction, and we have some points that we have to go through. So we're going to start up. We're going to work our way down through our first x-intercept, down to our absolute maximum, then we're going to come up to a local minimum, or excuse me, that's an absolute minimum. Then we're going to come up to a local maximum through the y-intercept, down to a local minimum, back through the x-intercept, and then our end behavior finishes in that direction. In this case, we know that as x comes from negative infinity, the y value is going to go to positive infinity. And as x goes to positive infinity, our y value also goes to positive infinity. So when we're writing our increasing or decreasing, we have 3 turning points that we have to consider. So right away we start out from negative infinity, and we're going to decrease all the way down to negative 2.77. So we're going to start at negative infinity in the x direction. This is decreasing. This is going to go negative infinity. And we're going to go all the way to negative 2.277. Neither one of these points are included. Then when we increase, we are going to start at negative 2.277. And we are going to increase all the way till we get to our local max, the x value, which is negative 0.65. And then we're going to decrease again. We're going to start where we left off, negative 0.65. And we're going to go all the way to the x value of our local minimum, which is 0.676. And then at that point, we're going to turn to increase, and we're going to go from 0.676 all the way to infinity. And so we can see that it is continuing. So we have answered all the questions. We see that we have an absolute minimum in this case. Then we have a local max and a local min. And then we have a pretty good sketch of what our graph should look like. And there is a little bit more accurate drawing of what it would look like, including our y-intercept.